Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is a mixed bag of possible exam questions, round 2, question 1. The formulas used are included in the video. The question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP exams and past papers, do not appear in most textbooks or the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. Okay, our question states, a cylinder with closed ends has an internal diameter of 100 millimeters and a wall thickness of 50 millimeters. The cylinder is simultaneously subjected to an internal pressure of 100 megapascals and an external pressure of 40 megapascals. Young's modulus is 200 GPa and Poisson's ratio is 0.3. Now we have to calculate the resultant hoop stress of both diameters, the resultant internal diameter and the resultant external diameter, and finally the resultant thickness of the cylinder wall. Okay, so first what we need to do is we are going to draw our graph of the cylinder. We're going to draw a graph of the cylinder, which looks something like this. Right, all we have is 0, 0, and it goes all the way from here to here. Okay, now this is at 40 megapascals and that is at 100 megapascals. This is 0.1. Now, what we're going to have to do is draw our cylinder, or draw the diameters of the cylinder. Okay, so what we have here is 100. This is 100 millimeters. And from there to there is 50. So if we want to get a diameter, because the wall thickness all the way through is 50. So if we want to get a diameter, we're going to have to go 50 plus 100 plus 50, which is equal to 200. So we have 0.2. Now we're going to put our values here, what we know. So our small diameter is 0.1, our big diameter is 0.2 meters. The wall thickness is 0.05. The wall thickness is 0.05 meters. Now the pressure internal is 100 times 10 to the 6 pascals. Pressure on the outside is 40 times 10 to the 6 pascals. Young's modulus equals 200 times 10 to the 9, and our Poisson's ratio equals 0.3. It has no SI unit. Poisson's ratio is no SI unit because it is a ratio. No ratio has a SI unit associated with it. Okay. First things first, we need to use our radial stress formula, which is right here. They're part of Lemay's equations. So, R equals A plus B over D squared. Okay, it can be any D. Okay, now we're going to work out A and B. So this is, now we're going to work at 0, 1. So that is at 100. 100 times 10 to the 6 equals A plus B over 0, 1 squared. Now 0, 1 over 0, 1 squared is exactly 100. So this is 100 times 10 to the 6 equals A plus 100 B. Now that's equation 1. Now we're going to work out equation 2. So it's 40 times 10 to the 6 equals A plus B over 0, 2 squared. Now 0, 2 squared, 1 over 0, 2 squared is exactly 25. So 40 times 10 to the 6, A plus 25 B. This is equation 2. Now to get a final answer, we say 1 minus 2. So equation 1 minus equation 2. So you will remember doing this type of thing. You will remember doing this type of thing in simultaneous equations in mathematics. So remember this by doing simultaneous equations. So 100 times 10 to the 6 equals A plus 100 B. Now this is 1 minus 2, so we got a minus here. So minus 40 times 10 to the 6 equals minus A minus 25 B. Now we minus them from each other. 100 minus 40 is 60 times 10 to the 6. A minus A is 0. So it's 0 plus 100 minus 25 is 75 B. Okay, now we're going to take 75B and divide 60 by 75B. So 60 times 10 to the 6 divided by 75 equals B. And we have done that. This comes out to B equals 800 times 10 to the 3 Pascal. So B equals 800 times 10 to the 3 Pascals. Now to get our A. So let's work out. Now we can take either sum and just stick it in. So let's stick it in with 100 because that'll be easier. So 100 times 10 to the 6 equals A plus 100 times 800. 800 times 10 to the 3. Now let's put that in our calculator. A plus 80 times 10 to the 6. 100 times 10 to the 6. Now, 100 minus 80 is 20. So 100 minus 80 is 20. So A equals 20 times 10 to the 6. So A equals 20 times 10 to the 6 pascals. Now we can work out the hoop stress. So all we have to do is say hoop stress. Now the formula for hoop stress is very similar to the one we've just used, in that all you have to change is A minus B over D squared. You just change the plus to a minus. That is all you have to do. So let's go. Right? H at 0,1. Now we will need the hoop stress later. So hoop at 0,1 will equal 20 times 10 to the 6 minus 800 times 10 to the 3 all over D, which is 0,1 squared. Alright, let's work it out. Let's work it out. 20 times 10 to the 6 minus 800 times 10 to the 3 all over 0,1 squared. This equals H 0,1 equals minus 60 times 10 to the 6 pascals. So this is a tensile load, not a, because if you're doing strength of materials, as we are, it says at the beginning of your textbook, all values associated with negative, and especially with due to loads, is a tensile load. The others, if it's a positive value, then it's a compressive load. Okay, so this is negative 60 times 10 to the 6 pascals. Now what we have to do is work out the next one. So H at 0,2, this is 20 times 10 to the 6 minus 800 times 10 to the 3 all over 0,2 squared. And this one, this particular one, equals 0 megapascals. So H 0,2 equals 0 times 10 to the 6 pascals. So H is 0,2, 0 times 10 to the 6 pascals. So now what we've got to do, now that we have our hoop stress, we can work out our resultant diameters according to this. So what we will need is the following. What we will need is the following. Hoop stress minus the radial stress. Okay, so what we have here is our, what we're trying to work out is equal to D over E times our hoop stress minus our Poisson's ratio times our radial stress. Okay, let's get to it. So we're going to do number 1 first. So equals 0,1 over 200 times 10 to the 9 multiplied by number 1 is a negative 60 times 10 to the 6 minus 0,3 times radial is 100. 100 times 10 to the 6. Okay. And that all equals minus 45 times 10 to the minus 6 meters. Now what we need to do is change it to millimeters, because that is what we are working with here and here, and change it to millimeters. So we're going to multiply by 1,000. We're going to multiply by 1,000. So minus 0,045 millimeters, which will make sense. Now what we have to do is take 100 plus, because this is an increase. This is an increase. Because we're increasing, because of the internal pressure, it's expanding. And also, the next one will also expand because it is an external pressure. However, the internal pressure is much greater, so it'll still expand. So 0,045. So 100, 0.045 millimeters. Now we need to do the next one. Now the next question is the very next thing, which is what we're going to do. So this is going to be D2. Okay, D2. So this one will be 0.2 over 200 times 10 to the 9 times hoop stress, 0 times 10 to the 6 minus 0.3 times my radial stress is 40 times 10 to the 6. Right, and all this comes out to negative 12 times 10 to the minus 6. So this is at, now we've got to multiply, now this is increased, because all negative answers have increased, because it's a tensile load. So it's expanded. So the next part is we multiply by 1,000. So 0,012 negative millimeters. That was meters. So we multiply by 1,000. Now what we will do is 200 plus 0,012 200,012 millimeters. So D2. Okay, now our final thing that we need to do is 1,4. Our final sum that we're doing is they want us to find the resultant thickness of the cylinder wall. which is quite simple to do. All we have to do is one little formula, and that goes thickness equals d minus d over 2. That is all we have to do. Okay. Now, what we have to do is also go now 200, 0, 0, 1, 2 minus 100, 0, 4, 5 all over 2. Now this equals exactly 49, okay, now what this will equal is 49, 983.5 millimeters. That is our final thickness. And I also forgot to put my final curve in for my hoop stress. This is radial and that is hoop stress. That's all our stresses. Okay, so what's going to happen? Now what we need to do is just minus the two top numbers and divide by 2. So that comes out to 49,983.5 millimeters. Okay, the reason it is slightly less, the reason this is slightly less than our starting thickness, it is because when the cylinder expands on the inside due to 100 megapascals of pressure, it actually thins out the cylinder wall very slightly. It thins out the cylinder wall slightly. So the more pressure you have, the thinner your cylinder wall, and the thinner your cylinder wall, the more likely it is to burst. Okay? But that'll take extreme pressure with us. So, and I've also put our other curve in here, because this is our hoop stress. And our hoop went from negative 60 to 0. Went from negative 60 to 0. That is our hoop stress. So it went all the way to the 0. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comment section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.